was changing between screens. Yeah, well, I mean, thanks to Steve for having us today. I'm really excited to talk to everybody. So we're Unstruck Data. Doug Rosen is head of sales. He's in the room, and he helped get us here today. So thanks to him as well. And today, really going to talk about something a little kind of on the flip side, maybe of some of the previous talks, but really just about the data itself. And so we are basically building an unstructured data warehouse for folks like Lariac and probably a lot of people in this space that just have a lot of unstructured data that they need to manage. And we're going to talk today about how to make that actionable. So we'll jump right into this. So really, what is unstructured data? And I saw a lot of drone data and a lot of other geospatially aligned data that in some of the other presentations, but what we consider unstructured data is everything from images and video to audio, might even be like a Zoom recording like this, documents and reports that are generated, as well as even, photogrammetry output, 3D geometry and point clouds. So when we talk unstructured data in this presentation, it's really a wide breadth of data types and stored in media files per se. How is it acquired? It's a lot of different things. We were just in Houston at a show for energy, drone, and robotics, saw a spot robot like this in the bottom left. There's a lot of drone vendors there. Even just mobile phones, are much more common these days. So the data acquisition kind of upstream from the things we're talking about, these days is happening across, a variety of different devices. And some automated and some kind of human managed. So who leverages this? It's folks, we talked to a lot of surveyors lately. We've talked to property managers, kind of engineers that are doing maintenance and tracking physical assets in the real world. And even, folks like drone pilots or robotics technicians for capturing the data. But then there's the other flip side of who wants to abstract information from this unstructured data? It's the business analysts. It's, potentially even the CIO or data managers. It's really a wide variety. There's a lot of folks that are leveraging it from a consumption standpoint, as well as, the upstream production of that data. And we're really discussing a lot of what we're doing with the breadth of all these folks, and even down to machine learning engineers and data scientists. So it touches a lot of different parts of industry, and we're really seeing it. Obviously today, public infrastructure. We've talked to several ports that Reuven mentioned. We've talked to different industrial work sites and manufacturing, oil and gas, and even, commercial real estate is anywhere where there's some type of inspection happening, looking for the state of a physical asset over time. We're seeing a lot of data acquired. The growth in unstructured data being acquired is really on an upswing. And that's what we're hopefully trying to lean in and help organize the data and make sense and value of that data. So an example use case, chemical plant maintenance, this would apply to a lot of other kind of site maintenance. There's a lot of kind of equipment and physical assets that are packed into a small amount of space, and they're doing monitoring. They're looking for problems. So thermal imaging using, FLIR cameras. They now exist. You can plug into your iPhone, or thermal imaging on a drone. It's, like from EagleView, the person from EagleView that was showing, capturing before and after data is really important to even maintenance folks. And so be able to track for anomalies. And so the unstructured data being captured is really a means to an end. And that's what we're seeing from folks we're talking to is the data acquisition, the creation of the unstructured data. There's not as much problem there. There's great drone vendors, great robotics vendors, but how do you find the problems at the end of the day? How do you create that business value or extract it? That's the tricky part. And that's what we're seeing a lot of people have trouble with these days. Another example is, what is called digital twins. Be able to integrate the concept of a real-time sensor with the physical asset in the real world. So cell phone towers, spread across hundreds of miles. So a lot of geospatial diversity, and trying to monitor the condition and the integrity of that. And it's not just, a geospatial kind of alignment, but it's time. I mean, how does this stuff change over time? How does weather and kind of external impact affect the physical assets? And the data correlation is really the other part of this that, I mean, we're really seeing a need for, where it's not just about taking a picture. I mean, a human can look at hundreds of pictures a day, analyze it for problems, but when you're getting into hundreds of thousands spread across hundreds of square miles and trying to correlate that to equipment IDs that are in an SAP database somewhere, or when did lightning strikes happen or rain conditions happen, that's where this gets to be an order of magnitude bigger problem. And so trying to pull all together data across those different axes and correlate that, that's where folks are having issues. And so it's not just volumes. I mean, that's one of the really big obvious areas where the amount of data you can analyze to what is captured is very small these days. I mean, there's a lot of great vendors that are helping in the tooling, but it's also about the semantic relationships. It's about what physical asset is this that I'm looking at in my image? But then there's also problems of, I mean, standardization of that data, and even, I mean, correlating that data in 3D space versus 2D space. A drone may be looking at a vehicle that's hundreds of meters away and trying to, I mean, do a geofence around where the drone was versus what it's looking at can be difficult. So trying to abstract that back to the 3D world from the 2D world is a requirement to be able to correlate these properly. And then even just segmenting the data. I mean, what am I looking at in this 2D image? What am I observing in this 3D point cloud generated from photogrammetry? The analysis side of this, I mean, how do you create structured data for analytics for other parts of your business workflow? That's a very, I mean, a tricky point. I mean, how do I put this into a Power BI dashboard per se? So we kind of see this as the general data flow. I mean, data acquisition, capture images off a drone, you ingest it into cloud storage or some kind of storage device. You enrich it, you can pull out metadata, you figure out the GPS location, you can layer in other data sources like tracking where the make and the model of the drone, and maybe even the maintenance history or of the drone itself. You want to be able to connect that up. And then the organization. I mean, how do I put this into a model where I can search and filter and kind of slice and dice that data and create views on that data, just like you would with structured data. So, I mean, if you're using Tableau or Power BI or something like this for structured data analytics, companies are wanting to do unstructured data analytics today. And that's the data needs to be organized properly to get in that mode. And then visualization. I mean, how do you browse the content? How do you just explore? It's kind of like a Google search versus just sort of, I mean, kind of just a way of exploring web pages. I mean, we want to have the ability to do both. You're going to find ad hoc relationships just by browsing what data is near other data or similar to other data. So you want to be able to support all of those workflows. So what we've looked at is, I mean, there's a need for what we call an unstructured data warehouse in the middle. It's not dissimilar from some structured data warehouses or other things like a customer data platform, where you're feeding all disparate data sources into one common container, one common funnel, and we create what's called a knowledge graph from this. So we're mapping together the media that is captured with the metadata enrichments, generating tags via computer vision, natural language processing, and then the end game is really generating insights. That's the business value. Like, I'm going to tell you a trend of maybe it's, I mean, taking drone photography of parks in LA, and I live in Echo Park. I mean, we've obviously had a lot of issues with, I mean, tents. And what if we wanted to track the trends of where are there tents being clustered in the park? Or are these the same tents moving around? Or are there more tents being added over time? Those are the insights. And be able to do that automatically without a human interaction is really the key, and the ability to do this at scale. So we want to have the ability to take in unstructured data from any source. I mean, Dropbox, Azure Blob Storage, Amazon S3, bring your own data into the system, sort of dump it in the hopper, generate knowledge from that, and then have the ability to have clients like a search, filter kind of interface, analytics, expose it via API so other systems can talk to it, have the ability to integrate with other systems like Esri or SAP, and have the ability to integrate workflows like Zapier. Like when something happens, tell someone about something else in your ecosystem, your data flow. And then the place this gets very specific is, I mean, looking from a drone down at a tent or a vehicle is very different than looking at an angle at a house from a 45-degree angle or something. And computer vision algorithms don't work well in a generalized sense. So training these, essentially with these enrichments on your data for your work use case is very important. I mean, companies today, I mean, iPhoto, Google Photos, find your dog and your kids very easily, but they're not trained for these kind of industrial enterprise outdoor types of data. And what we're looking at is easy ways to kind of do it by example. I mean, hey, show me where 4 tents are, or show me where 3 vehicles are. And we'll automatically create a computer vision model to then tell you about your data and find similarity later. And even more easily run analytics. And so, I mean, there's a classic problem of that data, there's too much volume to do it by a human, and you need to have that subject matter expertise of the human embedded into the system in a way that you could do it at scale. And so that we definitely want to play well, I mean, with others, and you can plug in other machine learning models. And we do see it as really, it's an ecosystem that no one company is going to be everything to everybody. So you need to be able to integrate and plug in with other providers. And so, I mean, as we said, what is the value of the data? It's the ability to ask questions of organized data. I mean, property management. I just moved my daughter into an apartment, and I could see that the property manager, I mean, what if they had taken pictures and done photogrammetry of this space and could actually track both in 2D and 3D the deterioration of that apartment over time? Even from an industrial case of, I mean, how bad is that leak on that oil tank? And the historical sense of, sure, you can look at it and say, look at pictures from each month, but what if you want to be told that there's a bad trend automatically? That's where having that data organized in a canonical form that you can run algorithms on makes sense. And even historical, I mean, yeah, like when did trees get cut down next to a construction site, or the tent example I was talking about? And it's really about letting your data tell the story. What are the characters of the data? And I mean, typically these are going to be the physical assets that you're looking at. I mean, the buildings, the vehicles, I mean, the equipment, pipes, things like that, are sort of the characters of your story. And what are the goals or objectives? I mean, do you just want counts? Do you want trends over time? Do you want clusters? That you kind of have to think of ahead of time, of how do you want to explain your data to other parts of your organization? Because it really isn't a one-person job. It's collaborating with the team, be able to comment, be able to share data, as well as kind of break down data silos where one group's data might live in the cloud, one group's data might live in an on-premise, I mean, hard drive somewhere. How do you tell stories across that data if it's not collated and in a way that it's really accessible by anybody, and even shared publicly? I mean, as we saw in the last talk, the ability to take a subset of your data and share it publicly is important. So this is where the data modeling is something we're very focused on, is coming up with a standard sort of vocabulary to talk about the data. One is what we call an observable. So it's something you can observe in the real world, like I talked about. Then it's the digital asset or digital media. Those are the files that you're capturing on your phone, the files that are come off or videos come off a drone. And then the observations, you could say this is sort of a tag that you say like, oh, I see a tree, or I see green. That can either be human generated observation or machine generated observation. And these can be as complicated as, I mean, identifying like a type of vehicle. I'm observing a truck versus a car, or it can be very generalized. It could be like, oh, it's cloudy. that day. And that could be an observation that was queried from a weather API somewhere. And so those observations can get built up, and you can have many observations of this thing in the real world. So as we talked about, I mean, it's really, to make this data actionable, you kind of have to focus on these different, what I call axes of how you align your data. And then we have some tips, about 4 or 5 slides more, of how to get the most out of your data. The one is, making sure you're not losing data. The metadata is data about the data that's inside of the files you're capturing. Drone vendors, even mobile phone vendors, they're storing metadata inside of the files, the images and the video, say in EXIF or XMP format. But you have to recognize the differences between the data formats, and some file formats don't support the same metadata as other formats. So if sort of naively we'd export data into a different format, we could lose that master data at capture time. We'll talk about it more in another slide, but I think one of our tips is really just be aware of the storage format, because you don't want to throw away good data early. 2 is location is everything. Every drone captures GPS location in the metadata, but if for some reason, maybe on a mobile phone, like location services are turned off, or there's some problem getting the GPS, it's really hard to get that information back. I had actually found a bug in one of the drone vendors' metadata where the GPS location was actually stored in multiple places in their metadata, in their files, and one of them was wrong. And so it was actually off by half the earth. And so those are the kind of things that, be aware of the data quality as you're capturing this data. It typically applies to images or video primarily, but data quality is everything. Same for time. This is a one that, we've gotten bitten. I think everybody's kind of been bitten at some point when, as you're copying files around, the date and time of when the file was captured can be easily lost. Typically, your Mac or Windows will have a date and time in the file system, like on disk where it's captured, but then there'll be a time and date in the file itself as well. And if not careful, some of this, we found this even sharing data in Slack, it'll strip metadata off. So if you're thinking about handing data to someone else in your team, be aware that, you don't want to strip that original data, because capture time can be very interesting. Was this captured in the spring? Was it captured in December? What time of morning? What time of the year? If you lose that and everything looks like it happened the day I uploaded it to the system, you're losing a lot of information. So tip number 3 is time. And then tags. It's just like going to the library. You have to have the data organized to find it again. And so my background was in the media and entertainment world, and there's a lot of structure around, when you put a video on Netflix, there's metadata about it. There's a structure on how do they categorize it, the genre, all of that. And this kind of data for industry is no different, where it takes a subject matter expert to say, here's the sort of organizational structure. Here's the aisle in the library that I want this to be kind of found, this book to be found on. That is really the best way to think. You have to think about that ahead of time and make sure you're categorizing the data, because once you have 5 years of data and 10 terabytes of data sitting on drive somewhere, it's hard to go back and add that taxonomy later, that organization later. And don't rely, one of our suggestions is don't rely on a file and folder structure. Folder names, I know a lot of people just use like a date stamp for a folder name or some short text folder name. It's a bit brittle, because as things move around, as you move data between your on-prem system and the cloud and vice versa, those folders can change. So if that's your only organizational method, you should think about having putting tags in the metadata, or having some other kind of database structure to store that. So you don't have the ability to break that link.
Okay, Kirk, you said we're closing out soon, or?
Yeah, I think just 2 more slides.
Okay, excellent.
Okay, I'll run quick. So really, what more can you do with it? It's about, as I said, collaboration, analytics, Quality is something that I think, we sort of took for granted in that we're trying to fix and control the quality of the data in our system, as well as deduplicating, showing you, hey, I accidentally copied this folder over to this folder under a new name. The ability to kind of keep an eye on your data and keep that quality level high is something really to think about. And then it's all about integration. What if I have something I've found in the data, who can I tell about it? How can I integrate with other members of my team? And so, yeah, to wrap up, there are standards, there are metadata standards that exist to help in these organizations. I'd be happy to talk about that with anyone. I think, you don't really have to drown in your data if you think about kind of pre-organizing this up front. And our goal is to, we're building a platform to help companies make sense out of and make your unstructured data actionable. And so really appreciate being here today, and I'm happy to answer any questions.